right. Hey, I got the right one on the screen now. Let's start up a new project here for Project Zero. Our little fighting pets, classes, pointers, dynamic memory, dealing with our copy constructor, copy constructor, or no, assignment operator, copy constructor, and copy assignment operator. My goodness, so many of these things, and the destructor. Right? If we've got dynamic memory, we're going to mess with all three to make sure we don't leave stuff hanging, which is all sorts of the fun stuff here. All right. So I like putting classes in their own files. You didn't have to, but I like doing that. So let's do that here. So we'll make a trainer class. So make our class for trainer. And it had a couple attributes, right? So trainer was going to have name, level experience points, max number of fighting pets, and a dynamic array of type fighting pet. So maybe I actually should do fighting pet first, because otherwise I won't be able to give all the attributes here. Let's go add another class then. My fighting pet. Class fighting pet. All right, so I'll have some private attributes, I'll have some public attributes, or public functions. That's how we usually do that, right? So fighting pets then have name, number, and combat power, sets and gets, and a constructor. These ones are pretty basic, right? Not too much going on there. I open that twice. So probably a string for name, right? So we should include string and use our namespace. Namespace, there we go. String for name. Wow, nope, there we go. Probably an integer for number, right? And maybe an int for combat power. I think those are usually whole numbers, right? Not doubles. It's been a little while. And then add a constructor, some sets and gets. So let's make a fighting pet constructor. I think the name is probably always going to stay the same, right? So if we take a name, take an int for number, that's all going to stay the same. Probably our combat power all stays the same. So you can take all these. This number is the number. What's the name and combat power? This arrow. There we go. This combat power is the combat power. All right. So we got a constructor. We need some gets in here then. Public string. No, sorry. String for get name. Can return name. An int for get number. Returns number. And an int for combat power. Get combat power. Returns the combat power. I don't know if we need sets for any of these really right now. We can see about that after, right? Yeah.
We're not supposed to do setters first before the getters?
I don't know if we need to set any of these because I think they're all probably pretty static. Like, or once you've assigned them in the constructor, we wouldn't need them. If you had sets, that's fine. It's just I don't think we're going to use them. But if we need them, we can add them later, right? So whatever kind of makes sense here.
I have sets after my gets, and then still want to run fine.
Yeah. If wherever you want to put them, it's okay.
Usually, do you put them first or after?
It doesn't matter. Yes. Some people put them all together. Some people put each attribute sets and gets together. I don't know. There's tools that'll format that stuff for you if there's a particular format you like. All right, so now we can do our trainer. So now we can include, go down one more line, include our fighting pet file. Cool. Which actually should get us the namespace and using string and all that stuff too, which is fun. So trainer then has a couple more attributes. We'll have our private section and our public section. All right. So we'll have a string for name. We'll have probably an integer for level. It's probably a whole number. Oops, level. I think experience points is probably an integer as well. Experience points. I don't know why. Max number of fighting pets is probably an integer. And the dynamic array of type fighting pet All right, so that'll be my fighting pet, array, pets, fighting pets. I don't know. What do we want to call it? Fighting pets, pets. Oh goodness, where's my that? Okay, I thought the red was still there, but that's okay. All right, so we've got that one. We'll get to these ones in a minute. We need sets and gets for name and max number of fighting pets. So those ones should change in case our name wants to change, and then get methods for everything else, right? So level and experience points will not change directly, but we'll have this add experience points that can go and affect them. So let's do all the gets first. So we'll do string for get name, returns name, int for get level, returns level, for get max number of fighting pets, return max number of fighting pets, experience points, int get experience points, return experience points. All right, and then we're going to do the sets for name and max number of fighting pets because those ones can change. So void set name takes the string for name. This name is the name. And set max number of fighting pets. Int max number of fighting pets. And we can set that one. Max number of fighting pets is my max number of fighting pets. So if we don't have sets for some of these other things, they've got to go in the constructor, right? So we should make our trainer class. Probably just take everything is fine, string for name, int for, now we could default them all to like level 1, or we could take a level in here. Either one's okay. We could experience points, like set them off at 0 experience points or take a number of experience points that they have. Depends how we want to load these things. This number of...
I noticed in silos in the chapter for classes and pointers, I think it might have been for the classes one, but it would have a default constructor and a parameterized constructor.
Yeah.
But are you able to kind of combine those? Or do you still want to have like a default and a...
So if you have attributes that don't have sets, you really can't have a default constructor because there's no way to set that value if you use the default constructor. So determining whether or not you want the default constructor kind of depends on if you can set all these things independently. If you can't, then you just can't use one.
Right.
So I don't know, they don't do a lot of the data hiding piece here where these things like don't change a lot. They'll just do sets and gets for everything, which for a lot of things is fine. Really just kind of depends what we're building here. So that's okay. And we should size that to max number of fighting pets. Oh dear, our fighting pets doesn't have a constructor. Okay, so we probably want a default constructor for fighting pet. That'll be useful for this. So I guess we need to have sets. All right, we'll go write them here. That's fine. Set name, string for name. Makes this a little easier here. Set name, void set number, number, set combat power, equals the combat power. Okay, now we've got sets, so I can write a default constructor if I wanted here then. So name equals nothing, number equals 0, and combat power is probably 0 as well, sure. All right. Now our array initialization is a little bit happier here. So make our array, yeah.
You spelled experience points, though.
Oh, did I? Experience points. I wonder which one of those, that one's not the right one. This is the right one here. Okay, thank you. Yeah, I wish I had spell check in here. That'd be nice. That's okay. So we're going to size this up, and now we need to know how many fighting pets we actually have, right? So like the idea is we're kind of like oversizing this just so we've got it. We don't need to do all the resizing every time. So we're probably going to add another attribute here for an int for number of fighting pets, right? But we don't need to give any access to this if we don't want to. Right? We don't need to make a public function for it if we're only using it internally, or maybe it's nice to know how many fighting pets I have, right? Not really sure. It's okay. Number of fighting pets. We'll start off at 0. If we need to use it later, we can add it later. If not, we can just kind of keep it as just something we use internally here. Okay. So, sorry, why is this beeping at me? My sugar's high. That's great. All right. So add experience points is probably the easiest one, right? It's probably a quick one to tackle, so we can have a method for add experience points. So here's all of our sets and gets. I don't know. I'll throw this one in the middle. So add experience points. Take in a number of experience points. Points to add. Sure. So someone had asked about this. If you go over this amount, do you keep the difference? Or like, are we just saying you ever add like 1 at a time or something? Like if we wanted to add 500 and we go over this number, do we keep the difference or does it really go back to 0? I think reading it this way, I was expecting it to go back to 0, but that does seem a little sad. Like if you were like 1 point away and got a bunch of experience points. So whichever way you did it was going to be fine. I'm not too concerned either way. So we can check. We can say, hey, my experience points, we'll add the experience points to add. And then we can check if my experience points is greater than or equal to my level times 1,000. Then we'll take our level plus, we'll take our experience points. How about minus the level times 1,000? I don't know. That way we get to keep the difference instead of going back to 0. Or if we just put it back to 0, that's fine too. Whichever one, or set back to 0. I think whichever way you want to go about it, right? That increases the level and either resets or keeps the difference. But we'll take away all those extra ones that you earned, right? Now, this isn't great if you earn like gazillions of points of experience all at once. Because if I like want to add 10,000 and then level 1, it's only ever going to put me to level 2. So that's like a little sad here. So maybe we could make this a while loop. And then I would, if I gained 10,000, I would level up 1, 2, 3, 4 times, right? Again, that's probably silly. I don't think we'd expect that sort of thing. But if that's what our code was supposed to do, right, that is something that could happen badly for us. And you can imagine in games that sort of thing could happen, right, if we're not thinking about it. So sure, I think making the while loop would be fine. And eventually this should probably stop working because we're taking away points as we go, right? Actually, we should do that first, shouldn't we? Because otherwise I'm going to take away too many points. Oh, goodness. I would have had another bug. Okay, so take away those number of points and then take the level up and then see if you have enough to go to the next level. Okay. All right. So we got add experience points. Now we want to add fighting pets. All right, so let's go add a fighting pet. Void add fighting pet. That takes a fighting pet. And we're going to add it to our array in the next open slot, or raise an exception if we have no more slots. Okay? So if you give me a fighting pet, I want to add it to my dynamic array of fighting pets at the index of where it should go. So first I can check and see, hey, if my number of fighting pets is equal to my max number of fighting pets, then I can throw that exception. This was no good, right? So we're going to throw, I don't know, a value error or something. Or was it error? Which, oh goodness. Argument exception. Bad exception. That's a fun one. What's the exception type we want?
Out of range.
Out of range? We can do out of range. Is that index out of range? Oh goodness. Do we have to import exception? I'm just going to throw exception right now because I'm really lazy. Throw exception. If you want to use the other ones, you got to import them. I didn't say which kind. It's probably better to do the right one, but this is okay for now. All right. We'll add a little fix me. Do use better exception. And then we'll come back to it. We'll make that later's problem, right? Because we're throwing an exception. We're not very specific right now. So if that doesn't happen, we don't really need an else block here. Again, trying to avoid how many times we tab in is nice. It's a good goal to have less tabs, because it just makes everything harder to see. All right, so if that's not true, then I can take my pets array at the number of fighting pets, and I can assign it to pet. Say, okay, you go here now. Let's go store it. Right? And then I can take my number of fighting pets, plus plus. Technically, you can put the plus plus in here if you want to be cute and save a line of code. I don't love that. I don't know. For some reason, I like it on the next line. It makes no difference, but sure. Okay, so we added the pet. Now we can be able to add pets. Now we need an add more fighting pet storage. Makes a larger size. Copies the fighting pets in the new array. Make sure we delete the other one. So sure, add more fighting pet storage. Add more fighting pet storage. Now, what do we want to know? Like, do we need to be changing any of our max number of fighting pets? Or, again, this is a little bit vague intentionally, because decisions have to be made when we write software, right? And either you're going to make up something that makes sense, or you're going to ask the person who asked you for this software what they wanted to do. Like, what did you mean by that? We're going to run into that all the time. Now, depending on how large an organization is, junior software developers sometimes get given very specific details, because we want to avoid this sort of back and forth hassle or having folks do the wrong thing. And by wrong thing, it's the thing we thought was the right thing that wasn't very clear, which is very interesting. There's a lot that goes into software engineering that's more than just writing code, right? Again, none of you have seen Office Space. It's sad, but you do need people to talk to people and to understand what people actually want with software. That gets to be interesting. So what did you guys do for add more fighting pet storage? Did you take like a number to increase, or did you just say, hey, if my max number of fighting pets is changed, or this was not super clear?
You made it manual, so you have to add whenever you want to add more storage. That's not automatic.
Well, so what sort of size did you do? Did you just double your storage, or?
No, I just added 3 each time.
Okay, so just added a couple. So we'll talk later about why that's slow, but we haven't got there yet. Let's see, I think that's coming up soon. Let me see, what chapter is that? Containers? Somewhere in here. Yeah, we'll get to those. So having to resize every 3, I guess depending on our game, we might not have to resize a lot, but generally you want to double so you don't have to resize very often. It gets to be less expensive. But sure, we got lots of options. We just add a little bit. That's fine. So if we want to make our array larger, I'm gonna key off my max number of fighting pets to see if something should happen, right? So we can say, hey, if because we'll just double it. That's fine. So we'll make a new array. So we're going to have new pet array. So new fighting pet, new pets, new pet equals a new fighting pet array of size. Let's do, I don't know, max times 2, max number of fighting pets. So number of fighting pets times 2. Make this larger. Is this way we're going to double? I don't know. I don't love this. It probably should key off of this, but it's okay. We'll figure it out. I guess we're not going to add more anyway, even if we have a larger array. So that should be safe, right? We're not going to add more pets. All right, so we've got the new pets array. Now we need to go through and copy, right? So for index is 0, index is less than my max number of fighting pets, index plus plus. We're going to go from the old pets to the new, or copy from the old pets to the new pets. So my new pets at the index can equal my current pets at the index. New pets at the index will equal the old one. Right, so copy them all over. When that one's done, then I want to delete my array of pets, and then I can say pets equals the new pets. Right, clear out the old one, and then change it to be the new one, so that I'm storing this new dynamic array in memory here. So let's make sure, and with the delete braces here to make sure we're deleting all of the array. Right, if you just do delete, it only deletes the first pointer. We might have stuff hanging somewhere. This is better to do this one so we don't leave anything hanging. Right, does that one seem straightforward? Doing a copy? Okay. Sure, so now we've added more storage. I like this one. All right, the last ones are destructor, copy constructor, copy assignment operator. The destructor is pretty quick and easy, right? We just need to go clean up after ourselves. That's the tilde character trainer to destruct. So we're going to delete my pets. Right? Make sure we clean up. Get rid of that memory that we have allocated dynamically. Right? Okay. Then our copy constructor, so a trainer given another trainer reference. I don't know, other or to copy or I don't know, lowercase t trainer. I don't know. Whatever you want to call it here. So if we're going to make a copy of this here, well, we can pretty much copy most of this stuff here, right? This will be the trainer.name, right? And trainer.level, and trainer.experience points, and trainer.max number of fighting pets. And number of fighting pets is trainer.number of fighting pets. But this one's a no good, right? We can't do this, right? We do want to allocate it to be new memory here, right? So I think that's fine. This number of fighting pets. I guess we don't need the this is here either, but that's fine. So we'll allocate our array, then we need to go through and copy, right? So for index is 0, index is less than my max number of fighting pets, max number of fighting pets, index plus plus. We're going to go copy from their pets to our pets. So my pets at index will equal the trainer.pets at the index. Go copy them over. Right? Cool? We're going so far. So this should be fine because fighting pet doesn't have any dynamic memory. We don't need to do any copies. If it did, we probably would have had a copy assignment operator. So if we were going to assign, it would have done all that memory copying for us, right? Because we've done the right thing all the way down the chain if we needed to. All right. So we got our copy constructor. I think we could add in the word const here too, right? We're just promising we're not going to change it. That's mostly optional, but it's just nice to show, hey, I'm not going to change the trainer that you give me here when we're making our copy. And then we need a trainer type here. It is from the operator equals, given a trainer, I don't know, trainer, and probably constant trainer, sure, why not? So if we want to assign something, so this is when we do exist, but we're going to change our values. So basically the same thing again, but now before we allocate our array of pets, we need to delete our old array of pets. Right? We're going to free up that memory we've allocated because I have allocated it, because this only works on a trainer object that's been instantiated already. Then we'll go through and copy. Right? You feeling okay so far? Cool. So we've got public get sets as needed for our trainer class. We've got destructor, copy constructor, copy assignment operator. We've got our dynamic array of fighting pets. We will resize the array as needed. Oh, this will resize it as needed or throw exceptions. Okay. So add fighting pet should make sure that if the size isn't big enough, it should resize. I think we sort of cheated by just making it larger, which is a little sad. But that's okay. I think it'll work the way we did it. So we just sized it oversized and went from there. And the fighting pet class was just a pretty basic class. Okay? Thoughts, questions? Dealing with dynamic memory sucks. It just does. But it's okay. It's not hard. It just is more steps we have to do to make sure we're being careful about it. And it does give us flexibility and power in how we deal with and allocate memory, which is super cool when you need it, right? Most of the time I just use vectors because I like vectors.
Will we do this later?
In life, yes, depending on what you're working on. So
Not in this class.
we're going to try and avoid dynamic memory from now on because it's obnoxious. Yeah.
So many syntax errors while I was like trying to work on it. Some that popped up with things that when I searched on like Stack Overflow or whatever, other people would say, "Hey, I have this error," but nobody would help them figure out what it was. So I'm like, "Oh, that's not good."
Not helpful errors. Oh
Yeah, I
no.
ended up commenting out some lines that I should have been able to get to work, but commenting out the lines made it run. So
Okay. Running's good.
yeah.
Should we try it and make sure it actually works then, like in our source file? All right, so let's include our trainer here. So let's make a pet. So let's make a fighting pet. Pet equals a fighting pet. No, we can just call the constructor here. So which one do we want? We want the one that takes parameters. I like the ones that take parameters, right? Which fighting pet do we want? Which one's the best fighting pet?
How about you two?
Mewtwo?
Third one, Pogo Brown.
I'm sorry?
For my third one, Pogo Brown. We have a lot of names.
What's his number? Is he 250
250
or 251 or something?
or 151.
150. Oh, that's right. Yeah, 150 in the first set.
Mew is 150.
And his combat power was something big, right? I don't even remember
At
here.
least 4.
We'll give him 100. Because why not? We can, right? All right, and then we need a trainer. So this is going to be Ash, of course, right? So we're going to have Ash, level 1, no experience points. Max number of fighting pets is probably 5 or something. I don't know. That's fine. And we can say Ash.add fighting pet, and we can give him our pet. And then we can start making copies and see, can we make these copies work, right? So let's make another trainer. Oh, is it Brock? Right, and Brock should be a copy then of Ash for now, which is silly, but we can go change his name later. Brock.setName, Brock. Now he should have Mewtwo as well, and we should be able to add to his list and not change Ash's list. Right, if we do this, so let's give him a pet. Let's make another pet. Fighting pet. Oh, what is he?
Geodude.
Geodude. There we go. Sure, Geodude. We're digging in deep here, right? In the lore. See how good your memory is this morning, Geodude. I don't number 27 something, doesn't really matter. 10 fighting power. Take Brock.add fighting pet. We'll add Geodude. Geodude? There we go. Geodude. All right. Now I don't really have a good way to get those back out though, do I? We never added a get pet option here. Those would be a little tricky to do that. Right? So maybe we want to add something, or we just run into debug mode. So debug mode sucks when you use dynamic memory too, though, to even like find those. How do we add a get fighting pet? This was just for our testing purposes here. So we can have a fighting pet, get fighting pet, get fighting pet. Maybe an int for the index that they're at or something. We can try that. We can return my pets at the index. Probably should check to make sure that's like a valid number, right? And all that sort of stuff. If my fighting, thank you. So if my index is greater than or equal to my number of fighting pets, we'll throw an exception. Throw exception, okay. That's fine for now, and then we can give back that pet. Is that gonna work for us? I guess if we copied it badly, we wouldn't have the right number here either, would we? I'm trying to see how we can break this. Like I want to get the whole list back and iterate over it or something, but that's all right. And then we should be able to go change some of those pets too, right? We can take Brock dot, we'll get the get fighting pet at 0, right? That should give me a fighting pet, and maybe I want to go set the name. I'm going to make this one Mew3, just for fun to see what happens. Now we should have new copies of these, right? Because we've copied these ones. So changing this one shouldn't have changed Ash's pet to make sure if we had the same array, right? I would change one and it would change in both places because we're both sharing the same array. So we'll just see out Ash's first pet. The Ash dot get fighting pet at 0 dot get name, and then line, and we'll do Brock's first fighting pet. See, testing like in the console with CIS is obnoxious, isn't it? It's annoying. Uh-oh. Didn't change his name. Well, remember when if I'm returning this, right? Am I returning a new value here or a reference there? Right? So should I return a fighting pet reference to the fighting pet? Let's try that. Now we can get Mew3, right? Because now I'm giving you a reference you can change and act on, rather than here's a copy behind the scenes. Right? Stuff gets weird. That's why it's good to run it. See what happens. All right, we okay? All right, let me go commit this to GitHub. 200. Project 0. All right, cool. Should we talk about the next project? You're all excited for the next one? Yeah, you're very excited, right? All right, let me go make a new link for you here. New GitHub repository. 200. 200, 2024, project 1. C++ template, there we go. One, this is inheritance and polymorphism. All right, so 2 weeks from today puts us at the 22nd, right? 9:30 in the morning. This one will be about 15 points if I remember right. Submit the URL of your repository. And then I'm just going to go shamelessly copy paste. Is that okay? Do you mind? From last time? I know you're all offended. Is that okay? That's fine. Okay, thank you. Let's see, where did it go? 200. Oh, they sort by alphabetical, so fall, all the falls get sorted before all the winters. It's so annoying. I think it was 1 here, right? Yeah, there we go. We're gonna do some silly things, because why not? This is fun. All right, so we're gonna make a class for character. Character is gonna have attributes for name, max hit points, current hit points, dexterity, X location, Y location, and a weapon. We'll have a constructor that accepts values for all our attributes. We'll have get functions for all our attributes, and we'll have set functions for X location, Y location, and weapon. The other things don't change, right? That's the idea here. We're gonna add a virtual function for attack, which accepts another character reference to attack. So characters can fight each other, right? If the character has 0 hit points, nothing happens. If you're dead, you can't attack anybody, even if you get asked to, because you're dead. You have no hit points. Or maybe if you're at 0 hit points, you might be unconscious, depending on how many turns it's been that you've been unconscious for, depending on what rule set we're playing with. If your character doesn't have a weapon, we use null pointer if there's no weapon. Their range is the square root of 2. So you can hit somebody in a square around you. Right? We're going to figure out distances, so that way you can do diagonals, you can do lefts and rights, up and downs. And if they hit, their attack does 1 damage. Okay. If the target is within range of the weapon, calculate the distance between the characters and check the weapon's range. You will roll a 20-sided die, and if the number is greater than the target's dexterity, it hits. If it hits, use the get damage function for the weapon to determine how many hit points the target is reduced by. So we've got hit points, right? Current hit points. We've got max hit points. We need to be able to take damage, essentially. We're going to change their hit points. So add a function for take damage that accepts the damage to take. We're going to change the character's hit points, but don't let it go below 0 or greater than the max. So you can, if you give it a negative number and you subtract negative numbers, it's adding, right? That's like, what level math is that? It's been a little while. We all know that works. Okay, you are all in calculus. And then we're going to make a subclass of character, which is a magic character. Magic characters have another attribute for intelligence. We're going to override their attack function that uses a magical attack instead of a weapon. If the target was in range of 10, we're going to roll a 20-sided die. If it's greater than the dexterity it hits, it'll take damage equal to their intelligence divided by 3, rounded down. So we'll do some magic damage, because we're magic. All right, then we're going to have a class for weapon. It has attributes for name, max damage, and range. We're going to have a virtual function for get damage that returns a random value between 1 and max damage. So when you get damage from a weapon, it could be the max, it could be 1, it'll be somewhere in the range. We just pick a random number in that range. And it'll make a subclass of weapon called a healing stick. Again, I'm bad at names, but that's okay. When you get damage, it returns a negative value instead. You beat someone with the healing stick and they gain hit points. Because it's okay, it doesn't have to make a lot of sense. Okay? So regular characters, magic characters, and then weapons and healing sticks weapons. So we'll do some bit of inheritance and polymorphism here. The cool thing is, right, if your attack takes another character, it can be character or a subclass of character, because they're all characters, right? With weapons, the take damage function will still work, but now all of a sudden we're giving negative numbers with this other subclass, because we can do funny things like that when we customize these behaviors. All right, so we'll do for website URL, we got the due date in here, let me go add a rubric. I think I did 12? 12 is lame, that's fine. Let's make this 15 points. This is for project 1. Use it for grading here. So having the character class, let's do is maybe 3 points here. And then the magic character class, let's do another 3 points. And then the weapon class, another 3 points. And the healing stick, healing stick class. And then let's do some unit tests too. Now there's not actually a whole lot to do. Like usually I do them by class, but that's okay. The subclasses are not going to have as much testing that needs to be done, because we don't need to test all of the other features again, right? We've done testing, right? We did testing? Okay. We didn't do it for the first project. We'll do it for this one. So we want to make sure that all the functions work, right? And the constructor works. So we're going to test the constructor, make sure all the values get set properly, and then we can test all the functions that do something here, right? Sure, sets will change, be able to set weapons, attacks here, within range, within not range, those sorts of things here. That make sense? Okay. All right, let me make that rubric. We good for now? All right, so we didn't get to finish the last little bit of, what was that chapter we were working on? I've not had enough coffee yet. Inheritance. We didn't get to abstract classes. We did a little bit of abstract, so the idea that we could have abstract functions, but we didn't get an abstract class yet. So we can talk about that on Tuesday. That should be fine. Because a little bit of time, so when we talk about containers, this will be pretty quick, I think. So we'll have a little bit of time to finish up inheritance on Tuesday. That sound good? All right, awesome. If you got anything else, let me know. If not, I'll see you on Tuesday. Enjoy the weirdly warm day. It's like in the 50s today, right?
Tomorrow's supposed to be like 57, I think.
Oh, it's February. Like, I didn't even get a chance to go sledding yet. I want to go sledding. All right, see you folks around.